In this video, I will show you how to perform a variety of transformations on a single point, the point 2, 3. So let's start with this function. We have f of 2x plus 3. So compared with the original function f of x, I see two transformations that are happening. So that means that we have to decide which transformations are happening to the y values and which transformations are happening to the x values. So any transformation that happens outside the function will happen to the y value, and any transformation that's inside of the function will happen to the x value. So this plus 3 means that we will everything will be moved up 3. So the y values will be increased by 3. That's because that's called a vertical translation up 3. So in terms of listing out the transformations, one of them will be simply up 3. Now, anything happening inside the function is going to be affecting the x values. So this is going to be something happening to the x values. We have learned that these transformations are the opposite of what they look like. So this is going to be a horizontal something, but the question is, will it be a stretch or a compression? It looks like it would be a stretch because 2 is bigger than 1. However, everything inside the function is the opposite of what it actually looks like. So because this is a 2, because this is bigger than 1, this will actually be a horizontal compression. And this is by a factor of 1/2. Okay, horizontal maybe I'll put a dot here to show where these start. So horizontal compression by a factor of 1/2. Of course, the 1/2 comes from doing the reciprocal. So this is happening to the x values, so my x values will become 1/2 of whatever they were. So these are the rules that I'm going to be using. I'm going to do half of all of the x values, and I'm going to take my y values and I'm going to add 3. So if I do that to the point 2, 3, the point 2, 3 is going to become, you know what, maybe I won't leave that much space. All right, we all know that we are starting with the point 2, 3. So this point is going to become 1/2 of 2 and 3 plus 3. All right, I'm taking half of the x and I'm adding 3 to the y value. So that is going to give me, well, half of 2 is 1, and 3 plus 3 is 6. So that's going to give me the point 1, 6. All right, let's look at problem number 17. What is going on here? I see this 4 outside the function. That's going to be doing something to the y values. Okay, this is going to be a vertical stretch. All right, vertical stretch. Vertical stretch by a factor of 4. The things that are happening to the y values outside the function, they happen just the way you would think. If it's bigger than 1, it's going to be a stretch. If it's less than 1, it's going to be a compression. All right, anything out here is happening to the y values. That's why this is vertical. All right, y values go up and down. So that means that my y values are going to be, they're going to be multiplied by 4. So it's going to be all about 4. Whoops, I don't know, I'm not sure why I put a comma right there. It's going to be 4 times my y values. Now, for my x values, they are being affected by this minus 2. Of course, that is a transformation of moving to the right by 2. Everything happening to the x values inside the function will be the opposite of the way they look. So you would think minus 2 would move you to the left, but actually it is going to be a translation right 2. Okay, so a translation to the right 2, that's going to be, we're going to take our x values and we're going to add 2 because it's to the right by 2. Okay, so that came from this guy right here. So these are the transformations. So now let's apply that to the point 2 comma 3. So we're going to have x plus 2, so that's going to become 2 plus 2. And I need to do 4 times y, so that's going to be 4 times 3. So that's going to give me 4 comma 12. All right, that would be the new point. All right, let's do the last one. I see 2 transformations outside the function. All right, I see one here and one here. Both of these are things that are happening to the y values. So that's why my y values will become negative y minus 4. Okay, negative because of that and minus 4 because of that. Now, what's going on inside the function? This guy is happening to the x value. However, oh, you know what? I'm supposed to be writing this down. Okay, let's write down the 2 transformations that I already mentioned. This negative sign in the front is a vertical flip, okay? It is a reflection over the x-axis. Okay, you could call that a vertical reflection if you wanted to. The minus 4 is simply down 4, a translation down 4. Now, let's talk about this 1/2. Everything inside the function is the opposite of what it seems. You would think that a 1/2 would be a compression, but it's actually going to be a stretch. So this is going to be a horizontal. Okay, everything inside of here is happening to the x values. So that's how you know it's horizontal, because the x values go to the left and to the right. So this is going to actually be a horizontal stretch. And we get the factor by doing the reciprocal here. So I'm going to say by a factor of 2. All right, and so because I'm stretching by a factor of 2, that's why my x values will be doubled. All right, so this is the rule that will transform each point. So if I apply that rule to the point 2 comma 3, I'm going to do 2 times the x value. So that's going to be 2 times 2. And then I'm going to do negative y minus 4. So that's going to be negative 3 minus 4. All right, I just did negative y minus 4. So that is going to give me 4 comma negative 7. All right, so that's how you can perform a variety of transformations on a particular point.